Section 7.4, periodic graphs and phase shifts. Today in this video, we're going to talk about graphing with the phase shifts. Now, for the first thing that I always do is I like to write down everything in my equation. And if we look at this value right here for this equation, if you look at your b value, notice it's attached to your x. The first thing you're going to want to do is factor that out so you can see what your phase shift is going to be. So for this, since it's a cosine graph, remember we have y equals a times the cosine of b factored out x minus c, which is really c over b if you're factoring it out, plus your d value. So in this case, if I factor that out, I get y equals 3 times the cosine, factor out the 1/2, and that means when you're factoring out, you're dividing it. So pi over 2 divided by 1/2, if I do it off to the side, divided by 1/2 means you're multiplying it by 2 over 1, gives you a value of pi. And so that would be my equation with my b value factored out. Now for this, I want to write down what everything means. So my a value, since it's cosine, it's going to be my amplitude. So remember that's a vertical stretch by a value of 3. And my b value is equal to 1/2. That's this value right here. And remember from that we can get the period of our function because the period is equal to your parent graph period, which in this case is 2 pi divided by your b value. So I know the period is going to be 4 pi. Then that helps me get my key points because you take your new period and divide it into 4 equal parts or multiply it by a fourth. So 4 pi times 1/4 gives me pi. My phase shift, my c value in this case, is going to be moving my graph to the right pi, so plus pi. And I know that my d value in this case is -2, so that means we're moving down 2. Now for this, you can go ahead and start to put your key points on your graph, or sometimes I like to wait because if we're not shifting by a key point, it's sometimes easier to have your key points made from a table. So I'm going to go ahead and make my table first and move that out of the way so I can do this. Remember, you always start with your parent t values when you're doing this. So my parent t values, just to start off with, remember we always start with 0. Then we have pi over 2. And then we have pi, 3 pi over 2, and 2 pi. And now if we look at our graph, that b value is 1/2. Since that b value is 1/2, remember that means we have a horizontal stretch by 1 over 1/2, so that gives me a horizontal stretch by 2. So because of that, remember when I'm changing my t values, I do 2 times all my t values because we're stretching all these parent graph t values out by 2. That's why I'm multiplying them by 2 in this case. So 2t times 0 would give me 0. So 2 times pi over 2 gives me pi. This would be 2 pi. This one's going to be 3 pi and 4 pi. And again, it makes sense because we did a horizontal stretch by 2, so we made our graph larger. Then what else am I doing to my x values? I also have a phase shift, and I'm moving my graph to the right pi, so that means I'm adding pi. Now notice in your equation it says minus pi, but remember we always do the opposite of our horizontal movements, so plus pi is what I'm going to use when I'm moving it. So in this case, if I do plus pi to everyone, I know that this is going to be 0 plus pi is pi. Pi plus pi gives me 2 pi. This would be 3 pi. This is going to be 4 pi and 5 pi. So those are the key points that I'm going to put down. Then the second part I'm going to do is I'm going to find my y values by plugging it into my entire equation. So in this case, I'm doing 3 times the cosine of 1/2 x minus pi over 2 minus 2 is what I'm really doing when I'm doing this. equation part. So when I plug in pi, well, pi times a half is pi over 2, and pi over 2 minus pi over 2 is 0. So we're going back to really these parent graph values. I'm just going down the line because when I do 1/2 x minus pi over 2, I undo the 2t plus the pi. So that means I have the cosine of 0, which is 1, and 1 times 3 gives me a value of 3, minus 2 is 1. So that value goes right here. Let me make this smaller. Oops. There we go. Oops. Okay, so this gives me a value of 1. Then when I plug in 2 pi times 1/2 gives me pi, and pi, or 2 pi over 2, and 2 pi over 2 minus pi over 2 gives me pi over 2. So the cosine of pi over 2 is 0, 0 times 3 is 0, and 0 minus 2 gives me negative 2. And then I'm going to keep on going. The next one, when I plug in 3 pi and I undo everything I did, I'm going to end up with pi. So the cosine of pi we know is equal to 0, and 0 times 3 is 0, minus 2, or sorry, cosine pi, sorry, is negative 1 times 3 gives me negative 3 minus 2 is negative 5. And then the next value is going to be negative 2 and 1 because we know they repeat. So on my graph, I'm going to do my key points. And for my key points, I'm going to skip every other one so that you guys can see what I'm doing. So this right here would be pi. This is going to be 2 pi, 3 pi, 4 pi, and 5 pi. And I can go backwards too. So this would be negative pi, negative 2 pi, negative 3 pi, and negative 4 pi. Okay. And then I have, I'll do this as 1, 2, 3. So that means this would be negative 5. Okay, so now I'm going to put my graph in. So for my graph, I know that I moved it down. We already changed our horizontal values by doing the new period with the key points. So then I'm moving my graph down too, so that means my new x-axis would be right here. Now that I've moved it down, I know that for this graph, we are doing a cosine graph. So cosine graph normally starts at 1, but we stretched our graph up by 3. So I'm going to count 1, 2, 3 up from my new x-axis that I have. And then the next point I know would be here. And then I'm going to count down 1, 2, 3 to get this point here and here. So this is a wavelength without my phase shift right here. So if I were to graph this without moving my graph to the right pi, this is what it would look like. But remember, that's not what our graph is because now I have to take all these points and I need to move them to the right pi. So if I move all my points to the right pi, I'm going to take this graph that I have right here and it gets moved to right here. And that, try to move it over, and that would be my graph shifted. So this right here would be my new equation for my graph. And again, all I did was graph it and then I shifted it to the right pi over 2. So if we check our values from the chart that we made, I should have pi comma 1. So if I look, I have pi 1. The next point that I'm going to have is 2 pi negative 2. So if I look 2 pi negative 2, which is what I have, and then I should have 3 pi negative 5, which I do, and then 4 pi negative 2, and then 5 pi 1. So all the points check out, so I did it correctly. And then, of course, remember my graph continues, so if I were to go backwards, the next point would be here, and this next point would be down here, and then here. So my graph would continue. So this would be a little bit more than one wavelength. So if I erase this part right here, that would be 2 cycles. So if I graphed it like this would be 2 cycles in my graph. And again, did this graph with our phase shift. So either way, if you want to graph it, making all the transformations on your graph and do it that way, that's fine. Or if you'd prefer to make the table, that's okay too. It's really up to you. So what I would do for this next one is I would see if you can maybe graph this on your own and then come back and we will graph it together. So I'd probably hit pause to see if you can do this. All right, so for number 2, same thing as the last one, I want to factor out that b value that I have. So when I factor out my b value, I get f of t is equal to 2 times the sine. I'm factoring out 4, which means I'm dividing it out. So I get t minus pi over 4 plus 3. So now I want to look at all my values and see what they are. My a value is the absolute value of 2, which is just 2. So that means I have a vertical stretch by 2. My b value is 4. Since my b value is 4, that's a horizontal compression by 1 over 4. Because remember, it's the opposite. If I know my b value, I can find my new period of the function. So in this case, I take my parent graph, which is 2 pi divided by my b values. So 2 pi divided by 4 gives me pi over 2. And then from there, of course, I can get my key points. So for my key points, I have pi over 2, and I divide it in 4 equal parts or multiply it by 1/4. So that gives me pi over 8. So that tells me what my key points are going by. My phase shift, or my c value in this case, is pi over 4. So I'm moving it to the right because it's minus. And then my d value in this case is equal to 3, which moves my graph up 3. So I'm going to do this one a little bit different this time. This time I'm going to go ahead. So this time I'm going to do the key points in my graph first before I make a table. So for this, I know that my key points are going by pi over 8, because that's what we wrote down. So right here would be pi over 8. So it's 1 pi over 8. The next one would be 2 pi over 8, which is just pi over 4. Then we have 3 pi over 8. And then we have 4 pi over 8, which is pi over 2. Then we have 5 pi over 8. And then the next one over here would be 6 pi over 8, which would be 3 pi over 4. And of course I could go backwards as 2. So this would be negative pi over 8, negative pi over 4, negative 3 pi over 8, and negative pi over 2. And again, if I look at my key points in my phase shift, I usually use that to help me determine whether or not it's a good idea to put my key points on my graph from my period, or to look at my phase shift, because sometimes it might be not a nice phase shift if it doesn't go exactly by your key point. So sometimes you'll just have to estimate. Now for this graph, notice that we shifted our graph up 3. So then that's the next thing I'm going to do is put in my vertical shift. So 1, 2. So this would be 5 up here. And this would be negative 5. So I'm moving up 1, 2, 3. So that's where my new x-axis would be. And for this graph, I know that my amplitude has changed. Now my amplitude is 2, and this is a sine graph. So normally it starts at 0. So I'm still going to start here. And then the next one, remember, would go up to 5 because the amplitude is 2. So the distance from here to wherever my x-axis shift to should be 2, which it is. The next point would be right here, which would be 0. And then we have here, because if you count down 2 from where your x-axis shifted, that's where your graph would be, and here. So this is my graph without a phase shift. So that would be y equals 2 times the sine of 4t and then plus 3. So that's that graph right there. However, remember, in this graph, we shifted it to the right pi over 4. So this is not my final graph. That means that I need to take each of these and shift them over a distance of pi over 4. Well, if you look at your key points, notice your key points are going by pi over 8. Pi over 4 would be the distance from here to here, which notice that it's 2 key points. So that means I'm moving my graph over by 2 key points. So that means that like this value right here would move over to not here, but right to there. So I'm going to take my graph and move it. And so this would shift my graph right here over pi over 4. So that would be my new graph. And then of course I could do another cycle. So if I did another cycle, the next point would be down here. And I think I'm a little off on the graph, so I'm going to bring that down a little bit. There we go. It's a little off. But the next key point would, of course, be down here. And then we would have here, and then here. And then since it's a sine graph, it would stop right there. So this would be a second cycle for my graph. And of course, I could keep going because remember, these graphs have a domain of negative infinity to infinity, so it doesn't stop there. If you want to make the table, you can do that. So now I'm going to do the table. So I start with my parent t-values. And of course, my parent t-values are 0. And we have pi over 2, pi, 3 pi over 2, and 2 pi. And then I do my horizontal shifts. So horizontally, I am compressing it by a fourth. So I'm going to do 1/4 all my parent graph t-values because I'm shrinking my graph in towards the y-axis when I do that. That's why I'm multiplying them by a fourth. So that's why you do the opposite. So for this, a fourth times 0 would be 0. A fourth times pi over 2 is pi over 8, which makes sense because that's my first key point. And then pi over 4 would be the next one, pi over 4, and then 3 pi over 8. And then if I do 1/4 times 2 pi, I get pi over 2, which makes sense because that is the distance horizontally it takes to make one wavelength, so that's the new period of the function. And then, of course, remember, we're also shifting our graph to the right pi, so I'm going to add pi, if not pi, but pi over 4 to each of those points that I have. So 0 plus pi over 4 is pi over 4. Pi over 4 plus pi over 8, you would need a common denominator, so that would be 2 pi over 4 over 8 plus pi over 8 is 3 pi over 8. And then the next one would be pi over 4 plus pi over 4 would be 2 pi over 4, which is pi over 2. And then pi over 4 plus 3 pi over 8, again, you need a common denominator, so that would become 2 pi over 8 plus 3 pi over 8, which gives us 5 pi over 8. And then for the next one, same thing, pi over 4 plus pi over 2 would need a common denominator, so this would be 2 pi over 4, which gives me 3 pi over 4. And so that's where my graph has moved to. And then I'm going to do my my vertical transformations. So for my vertical transformations, I'm just plugging them into the equation. We have y equals 2 times the sine of 4t minus pi plus 3. I'm going to shrink that down so it fits. That goes there. And then I'm just plugging into my equation. So when we did our horizontal transformations, we did the opposite because when I plugged these numbers in, it's going to undo it. So 4 times pi over 4 is really pi, and pi minus pi is 0, so that's why it gives me my parent graph 0 here. The sine of 0 is 0, and 0 times 2 is 0, and 0 plus 3 would be 3. So on my graph, I should have pi over 4, 3. So if I look, pi over 4, 1, 2, 3, which is this point right here, so that point checks out. And then I'm going to keep on going. When I plug 3 pi over 8 times 4 minus pi, I get pi over 2. The sine of pi over 2 is a value of 1. 1 times 2 is 2. And 2 plus 3 is 5, so I should have 3 pi over 8, 5, which is this point up here, so that checks out. And then I'm going to keep on going. When I plug in pi over 2 into my equation, times 4, and then minus pi, I end up with pi pi, so the sine of pi is equal to 0. 0 times 2 would give me 0 plus 3, so this is 3 here. And then when I plug in 5 pi over 8 times 4 minus pi, I get 3 pi over 2. The sine of 3 pi over 2 is negative 1 times 2 would be negative 2 plus 3 would be 1. And then this one right here would end up being 3. And then, of course, I would check the rest of those on my graph to make sure they came out okay. So two different ways of graphing. Like I said, if you don't like making the table, that's okay. If you like making it, that's okay too. But if you're going to do the transformations on the graph, I would probably show all of them so that you don't miss something.